Multilabel toxic comment detection and classification. Abstract toxic comments refers to hatred online comments classified as disrespectful or abusive towards individual or community. With a boom of internet, lot of users are brought to online social discussion platforms. These platforms are created to exchange ideas, learning new things and have meaningful conversations. But due to toxic comments, many users are not able to put their points in online discussions. This degrades quality of discussion. In this paper we will check the toxicity of comment. And if the comment is toxic, then classify the comments into different categories to examine the type of toxicity. We will utilize different machine learning and deep learning algorithms on our dataset and select the best algorithms based on our evaluation methodology. Moving forward, we seek to attain high performance through our machine learning and deep learning models, which will help in limiting the toxicity present on various discussion sites. Keywords: toxic comments, natural language processing, machine learning, deep learning, text classification, multilabel classification. Introduction. There is increase in number of people using Internet. Internet is main invention for 21st century. According to website, the number of Internet users have increased from 1,100 million in 2005 to 3,969 million users in 2019, which is staggering 260% increase. Hence, more people are using social networking and online discussion platforms. There is also a huge shift the way Internet is used. In the initial days of the Internet, people used to communicate with each other through email. But with a platform like social media, we see that people got a way to keep in touch with their long-lasting friends, meet new peoples having same interests and hobbies. We are now more connected than ever. Not only discussion of friends and people, but social media has also evolved to support business needs. With increase in services like gaming and live streaming, more velocity of comments is added to sites. Social media has broken down many of the communication barriers between different consumer groups as well as between individuals. Hence, no doubt that social media sites such as Facebook, Twitter, Reddit, etc. have become billion-dollar companies. Over these all years we have seen lot of instances where social media have played pivot role due to toxic comments and hatred. For example, Chief Minister of Uttar Pradesh State of India blamed social media like Facebook, Twitter, and YouTube for escalating tensions during communal conflict between Hindu and Muslim community in Muzaffarnagar, India in 2013 too. Colombo's police booked a man for abusing and threatening the police via a comment on a Facebook post. 3. Another example is of riots that took place in Djhalli, Bengaluru, India in 2020 over a provocative Facebook post against Islam that left 3 dead and many injured. 4. On January 6, 2021, U.S. Capitol riots took place by supporter of Donald Trump. Many extremists had posted on social networking sites posts such as Occupy the Capitol, Bring Revolution, etc. before riots. 5. Hence, it is very important to detect such threats, hatred, toxicity on online discussion platforms and social networking sites. Because not doing so can cause violence, riots, prevent good debates, make Internet an unsafe place and can affect people mentally. Let us take an example of comment present in our dataset: just shut up and stay shut. Don't edit anymore. It can be easily identified that the phrases like shut up, don't edit anymore, etc. are negative and thus this comment is toxic. But besides toxic, we need to go through series of steps to classify comment using machine learning classification algorithms to verify type of toxicity of obtained results. We will use different machine learning and deep learning models on our dataset, which is made available by conventional AI in Kaggle.com. In this paper we will use logistic regression and support vector machine models with TF-IDF vectorizer, long short-term memory with GLOVE and WORD2VEC embedding. We have used all models on given dataset and compare their scores to find which one will be best. The rest of the paper is arranged as follows. All the recent approaches being used for text classification and natural language processing have been elaborated in Section 2. Section 3 contains the proposed methodology, different machine learning models and evaluation metric that is used. Section 4 contains results and analysis. The paper ends with conclusion in Section V. 2 related work. There is lot of information being delivered every time on social media sites. There is increase in hate speech that both may promotes violence towards Muslims and Arabs after following extremist violence events. 6. Because of this negativity, particular community might feel insecurity while utilizing social platforms. There was survey conducted asking American adult about problem of online harassment or bullying. Roughly 4 in 10 Americans have personally experienced online harassment. 62% of participant in study considered it as major problem, whereas 33% considered as minor problem. A total of 95% called it problem and 35% agreed for online companies to build better policies and tools for their platform. 7. Due to negativity, civilized conversations via social media are not present since hateful remarks are limiting individual to communicate and to have contradicting feelings. 8. There were endeavors by people to build the online well-being by moderating websites through crowdsourcing schemes and remark criticizing. Much of the time these procedures neglect to recognize the toxicity. 9. Along these lines, we need to track down a potential method that can recognize the online toxicity of client content successfully. 10. As computer understands binary information, and in real world we have information in different structures, for example pictures or text. So, we need to change over the information of real world into binary for legitimate processing through the computer. In this paper, they have utilized this changed over information and apply machine learning strategies to arrange online remarks. 11. When 12 made model consisting of 2 components: deep learning classifier and tweet processor. Tweet processor is used for applying semantic rules and pre-processing on datasets to capture important information. They used character-level embeddings to increase information for word-level embedding. They then used deep CNN for character-level embeddings. After that, a bidirection long short-term memory network, BiLSTM, produces a sentence-wide feature representation from the global fixed-size feature and word-level embedding. Their model produce an accuracy of 86.63% on Stanford Twitter sentiment corpus. Liangqi UETAL 13 proposes a word vector refinement model. This refinement can be applied to any of already trained word vectors. Based on semicolon lexicon, their model gives high rank to sentimentally similar neighbor and vice versa. Their experimental results show that their proposed method can perform better for various neural networks. It also have better performance for both sentimental embedding and conventional word embeddings. A method was introduced by Wulchen et al. 14 develop method to analyze personal attacks. They generated over 6.3M machine-labeled and 100K human-labeled comments. They found that attacks on Wikipedia are not limited to a set of users. Hossein Hosseini et al. 15 apply the attack on the prospective toxic comment detection website. This website gives toxic score to any phrase. They tried to modify a toxic phrase having same meaning so that model will give it very low toxic scores. This existence is harmful for toxic detection system. In another methodology, convolutional neural networks, CNN, was utilized in text characterization over online substance. 16, with no information on syntactic or semantic language. Chen et al. 17 propose the lexical syntactic feature, LSF, architecture to distinguish offensive content and recognize likely offensive clients in web-based media. Their experiments shows that LSF algorithms for sentence and user offensiveness outperform traditional learning-based methods. Their LSF can adapt to various writing styles of English language and can tolerate informal and misspelled content. Jigsaw and Google's counter-abuse technology team introduce project named Perspective. It uses machine learning models to identify abusive comments. The models score a phrase based on the perceived impact the text may have in a conversation and have capability to classifying comments. Nave O'Neill Chakrabarty 18 utilizes machine learning model on Jigsaw toxic comment detection dataset to label toxicity of comments and produce the mean validation accuracy, so obtained, is 98.08%. 3. Proposed methodology. In this paper, we take a dataset provided in Kaggle website provided by conventional AI. It is collection of large number of comments in Wikipedia website and labeled as toxic, severe toxic, threat, identity hate, obscene and insult. The advantage of this type of data is that these comments represent a true sample of the content present on the social media sites. We first ran analysis and visualization on this data, which we have discussed in section IIIB. For our machine learning model, we have removed outliers and noise which is present as data. We initially tested the performance of classical models, namely, support vector machine and logistic regression on this task with TF-IDF vectorizer. We then applied pre-trained embeddings, namely GLOVE and WORD2VEC in our model and performed the classification. We compared the performance of all the models using the mean AUC ROC score, Hamming and log loss as the performance metric. A type of classification. As discussed above, our dataset have 6 categories, i.e., threat, insult, toxic, severe toxic, obscene, or identity hate. Hence our problem can belong to multi-class or multilabel classification problem. As we can see the above description, this problem is a multi-class classification as well as multi-label classification problem. Multi-class classification. In this classification we put each example into one of the several possible categories, unlike binary classification problem where each example belongs to only one of 2 possible categories. Multi-label classification. This type of classification involves examples such that each example can belong to multiple categories and not necessarily only one category. A multi-label classification problem can be viewed as a generalized version of the multi-class classification problem, in which there is no restriction over how many classes a training example can belong to. As in our data set, our data can belong to 0 to any number of categories, hence our problem is multi-label classification problem. B. Data visualization. Data visualization helps us get visual insights about the data set, helping us to find patterns and features of data for selecting right machine learning algorithms and evaluation metrics. We plotted a pie chart in figure 1, showing the relative amount of hate tags present in the dataset and found a massive class imbalance. Toxic tags were the highest, whereas tags labeled with threat had the lowest count. Also, plotting a bar graph figure 2 after adding a column for clean tags, we found that most of comments are clean. A picture containing shape. Description automatically generated. Chart. Description automatically generated. From figure 5, it is quite evident that most of toxic comment have only one label, but there are some tags with 2, 3, and 4 labels, hence problem is multi-label classification problem. C. Data pre-processing. We have used both machine learning and deep learning models over our data set. We have used TF-IDF vectorizer with machine learning models, logistic regression and SVM, and GLOVE and WORD2VEC embedding with LSTM. Raw text cannot directly be input to any machine learning algorithms. Some of most popular technique for converting text into numerical features are bag of words, TF-IDF WORD2VEC, and GLOVE. One-term frequency inverse document frequency, TF-IDF, vectorizer. This vectorizer normalizes the text. It reduces the weight of tokens that are occurring multiple times in documents. It is made in such a way that its value increases if the frequency of term is more in a document and value decreases if term occurs in multiple documents. It consists of 2 parameters: term frequency, TF, and inverse document frequency, IDF. Term frequency, this calculates the frequency of a term in a document. This is like the count vectorizer method of encoding text. 2. GLOVE word embedding. Word embeddings are used to represent words in structured format. Because most of the data in internet is not structured, word embeddings techniques are a useful tool to transform data into more structured format so that useful information can be extracted. In bag of words models, feature extraction can be done, but they fail to capture any semantic or contextual information in texts. One-hot encoded vectors may lead to a highly sparse structure which causes the model to overfit. To overcome these shortcomings of the above approach, word embeddings are used. Word embeddings represent words in the form of vectors in predefined dense vector space. These vectors contain meaningful semantic information about the words. The idea in this approach is words with similar semantic information are like each other. Hence, the similar words will be in proximity within the high-dimensional vector space. Hence, we can significantly reduce the vector size in contrast to the one-encoding technique. Pre-trained word embeddings are obtained by unsupervised training of a model on a large corpus. As they are trained on a large corpus, they capture the semantic information of most of the words. These pre-trained embeddings are provided by different companies and organizations for open use. GLOVE stands for Global Vectors. It is provided by Stanford as an open source project. In this approach, a word co-occurrence matrix is constructed. This helps in capturing the semantic information. The co-occurrence matrix stores information about the frequency that appear in some context. Thus, it takes both local statistics and global statistics into account to obtain the embeddings. 3WORD2VEC. It is one of the earliest pre-trained embedding. It has two flavors. First is skipgram model, where the algorithm tries to predict the context or surrounding words in which the word would have been used. It learns by predicting the surrounding words given a current word. Second is continuous bag of words, CBOW, model, where the algorithm tries to predict the word if a context is given. In this way, the word embeddings vectors are generated. D. Machine learning models. 1. Logistic regression. Logistic regression is the fitting regression analysis to use when the reliant variable has a binary answer. Like any remaining kinds of regression frameworks, logistic regression is likewise a predictive regression framework. Logistic regression is utilized to assess the connection between one reliant variable and one or more non-reliant variable. It gives discrete yields going somewhere in the range of 0 and 1. Logistic regression utilizes a more complex cost function. This cost function is known as the sigmoid function, or otherwise called the logistic function. Equals 11 plus dash. In our case, we have used logistic regression for prediction in each class, i.e., toxic, severe toxic, threat, identity hate, obscene and insult, and mean score. 2. Support vector machine. Support vector machines use the concept of support vectors and hyperplanes for classification tasks. They can be used for both regression and classification tasks, but are more popular for classification. They can be used for both linear and nonlinear data. It works by constructing an optimal hyperplane in an n-dimensional space, i.e., a boundary separating the data points, such that the margins between the support vectors is maximized. Support vectors refers to the data points which are closest to the hyperplane and are useful for training tasks, and the margin refers to the distance between the two parallel lines passing through the closest support vectors on either side of the hyperplane. In case of nonlinearly separable data, it transforms the original data into higher dimensions for classification task. It is also known that SVM perform excellent for higher dimensional data because complexity of SVM does not depend on dimensionality of data used but on number of support vectors. This also helps it to be memory efficient. Chart, radar chart. Description automatically generated. In our case, we have used support vector machine with binary relevance and classifier chains for predictions. In binary relevance method, we transform the problem into separate single-class classification problems, each of the problems having a single label. We then apply the support vector machine on each problem separately to get the result. After that, the results of each problems can be combined to get all the labels for a comment. Simple it is, it comes with drawbacks. It ignores any correlation between the labels. Hence it will give poor results if there is correlation between labels. In classifier chain method, we transform the problem into separate single-label classification problems, such that if H classifier is trained on input variable S, then +1, H classifier is trained on input variable and output produced by H classifier. Hence, this technique considers the correlation between the labels, since for every new classifier, the predictions of the previous classifiers are considered, i.e., for a given target variable, it also considers the correlation between previous target variables. 3. Long short-term memory. Artificial neural network is a layered design of connected neurons, enlivened by natural neural network. It is not one algorithm yet mixes of different algorithm which permits us to do complex procedure on data. Recurrent neural networks, RNN, is a class of neural networks customized to manage worldly information. The neurons of RNN have a cell state/memory, and input is handled by this interior state, which is accomplished with the assistance of loops within the neural networks. There is repeating module of H layers in RNNs that permit them to hold data but not for too long. This is the reason we need LSTM models. LSTM are special recurrent neural network that can capture long-term dependencies. The cell state is regulated using gates which determine the amount of information that will flow through them. It has cell state, along with hidden states which stores information. This information can travel through cell state without any change, hence, preserving long-term dependencies. For result and analysis. After applying 3 different machine learning models to our dataset, we got the result in form of ROC-AUC, accuracy, Hamming loss, and log loss. After analysis results, we can say that LSTM with glove embedding performs the best because it has highest ROC-AUC score and lowest Hamming loss and one of the lowest log loss among all models, which means that there is very less multilabel are accurately measured. LSTM with WORD2VEC embedding has also performed comparable to LSTM with glove embedding. We also observe that classifier SVM performs better than binary relevance SVM, which was expected. Both Hamming loss and log loss in all our models are lower than the algorithms presented in 20. It was expected for deep learning model LSTM to have best result over all the algorithms. Conclusion. We compared the performance of the model based on the mean ROC-AUC scores, Hamming and log loss. Hamming and log loss of classical models are more than deep learning LSTM model. We also found out that the classifier chain method performed slightly better than binary relevance in this task. LSTM model outperformed other models in this task. We can further test the performance of state-of-the-art models like transformers on this task. BERT, bidirectional encoder representations from transformers, caused stir in machine learning community by presenting state-of-the-art results in wide NLP tasks. BERT can be used for this problem in future. We can also experiment with more sophisticated models like GRUS. We can also combine machine learning models together for this problem. We can ensemble the results obtained from the various models in a majority vote fashion.